This is the Rethink Respironics shared manifold ventilator, designed by Colby Shepard, William Barrett, Noel Mills, Jacob Scrontz, and Taylor Suber. This project is meant to create a shared ventilator that will allow multiple patients to be simultaneously ventilated. It is also meant to cut costs on ventilation and to be produced in areas where funding is not readily available to hospitals.
The most important specification listed here is that the shared manifold ventilator will support 3 patients, and to verify this, 3 test balloons will be attached to the ventilator alongside with several sensors. Looking at the concept of operation, the shared manifold ventilator can provide ventilation to 3 patients simultaneously and safely with the use of solenoid valves to control the mixture and flow of the air and oxygen. Each patient air pathway is identical and highly controlled by using several sensors.
Looking at the overall view, the oxygen and air supply will both be controlled by solenoid valves. They will go through a HEPA filter and combine before then going to the patient. When the patient breathes out with the help of another solenoid valve, the exhaust will go through a HEPA filter and release into the atmosphere. For the nurse's stand, we'll be using a laptop that uses LabVIEW to collect patient vitals and show patient inputs. The screen will show patient's name, ID number, and inputs such as flow rate, tidal volume, and FiO2 rate for each patient. There will be a diagnostic screen that collects data for sensors which will trigger alarms if needed. The patient stand is a handheld device that has a red assistance button to get the nurse's attention if needed and a dial for the patient to change their breathing rate. There is a 7-segment display of heart rate and breathing rate for patients to see, and a pulse oximeter will be used, which will be 3D printed.
It is extremely important for ventilators to be safe for their patients, so we have system pressure, PEEP, blood oxygen levels, heart rate, and airflow monitoring throughout each system and each patient, as well as electrical redundancy for components and power supply and HEPA filters for safety. The diagram you see on this slide is the system structure for the entire ventilator, and this allows for 3 patient ventilation simultaneously. Each airflow path is controlled individually for each patient to accommodate each patient's needs, and the system is expandable for more patients via a larger blower and additional patient branches if needed for more patients.
2 Arduinos will be implemented in our system. One at the patient stand, reading data from the patient side sensors, and another at the nurse's stand, controlling the solenoid valves and reading sensors embedded into the system. Both will have a display to view these values easily with the nurse's display showing all the readings from both boards. A 433 MHz transmitter will be used to communicate between the boards.
For the upcoming spring semester, our team plans to build a proof of concept capable of supporting 3 patients, allowing breath rate control, holding a constant pressure, and venting any extra unhealthy pressure. Calculations will be finalized so the design is safe and effective for use.